In this video we're going to be looking at rational functions where we now have polynomials on the numerator as well, seeing how this can mix things up. I'm going to be working through two examples in this video. We've got y is equal to x plus 5 over x minus 2 and y is equal to 3x minus 2 over 5 minus x. Okay, so I'm going to start off with this first one. And the first thing that we do is we look for vertical asymptotes first. Where can the denominator be 0? And that will be when x is equal to 2. That's the only value that will make the denominator 0. And so we know that things go wrong when x is equal to 2. So we put that in with a dotted line. Now, we might also be interested in where it crosses the x-axis. And that is when the numerator is 0. So the numerator can be 0 this time, and that's when x is equal to minus 5. And so I do know that the curve crosses the x-axis at minus 5. Okay? I know that bit of information. So that's when the numerator is 0. How about a horizontal asymptote? Now, it's not immediately obvious for a horizontal asymptote as to how to find it for this one, because we've got x plus 5 on the top and x minus 2 on the bottom. When x is very, very large, if you put in x is 1,000, for example, you're going to get 1,005 divided by 998. And the larger value of x that you put in, you will find that the y will approach y equals 1. Now, the way that that can be seen is that you can divide top and bottom of the fraction by that largest power of x, the x there. So if you divide top and bottom by x, you get 1 plus 5 over x over 1 take away 2 over x. Now, as x gets larger and larger and larger and larger, the 5 over x and the 2 over x both get smaller and smaller and smaller. And as we go to very large values of x, they become insignificant. And you're just going to get left with 1 over 1. So y equals 1 is my horizontal asymptote. So I can put that in. That's y is equal to 1. So I know that for large values of x, and for, in the positive direction and in the negative direction, the curve will approach this line. So, I know that the curve cuts the x-axis at minus 5. Does it cross the y-axis? I would assume that it does. In order for it to cross here, it must probably cross here in order to then approach x is equal to 2. So when x is 0, we get y is equal to 5. So 0 plus 5 over 0 minus 2. So we get minus 5 halves. So the curve will look something like this. I mean, that's not particularly neat. It more looks like this as it approaches that horizontal asymptote. Okay, so it must do this. Now to the right of that vertical asymptote, the x is equal to 2, we've got a choice. Is it in the top half or the bottom half? Now if it was in the bottom half, you would find that the curve would have to then cross the x-axis, but in order to approach this y is equal to 1. But we know that it doesn't, and so the curve must be in the top half. Now you can also check that by substituting in any value of x that is larger than 2 into this equation. So if you tried x is 10, for example, you'd get 15 over 8, which is positive, and so it must be above the line. Okay, so that's my first example. So the real changes here in comparison to the previous ones that we've looked at in the previous videos, is that we now have graphs that will cross the x-axis, and we have graphs that are looking like they've got asymptotes at values other than y is equal to 0. Alright, let's look at the second one. So first off, vertical asymptotes. That's when the denominator is 0, so that would be x is equal to 5. There's x is 5. Then you also want to be looking at where does it cross the x-axis. That's when the numerator is 0. So the numerator will be 0 when 3x minus 2 is 0. So x is equal to 2/3. So 2/3 is approximately here. So that's where the curve crosses the x-axis. How about horizontal asymptote? Okay, so I can use a similar technique to what I did here. Divide top and bottom by x. We're going to get 3, take away 2 over x, over 5 over x, take away 1. So as x becomes very, very large, either positive or negative, the 2 over x and the 5 over x will disappear, and we'll get left with 3 over minus 1. So that would be minus 3. So we would expect a horizontal asymptote as y at y is equal to minus 3. Right, okay. So, how about where it crosses the y-axis? We've got the vertical asymptote, horizontal asymptote, and where it crosses the x-axis, but not where it crosses the y-axis. That's when x is 0. So when x is 0, we're going to get minus 2 over 5. So minus 2/5. So minus 2/5 is approximately here. So you can see that in order to approach this line, the curve must do something like that in order to pass through those 2 points. Now, if that's how the curve behaves on the left-hand side of that vertical asymptote, on the right-hand side we've got choices. We've got the top or we've got the bottom. Now, if it were to be on the top, that means it would have to cross the x-axis in order to start approaching y is equal to minus 3. But we know that it doesn't. So, the only choice is that the curve must be here. Now you can always substitute in a value like we did last time. We could try x is 6, for example. So we get 18, take away 2, so 16 over minus 1, so minus 16. So when x is 6, we get y is equal to minus 16, which is down here. And so we know that the curve must be located in this region. Okay? And that's how we would sketch both of those functions.